If you haven't already tried example 2 on your own, I strongly encourage you to do that before viewing this. But in this particular example, we're going to be answering a few questions about a series circuit with 2 resistors. Here we're given the values of the resistors and the total voltage of the circuit. We're asked to find the current through each resistor, as well as the voltage drop across each resistor. And finally, in part C, we're asked to find the total voltage drop across the circuit. Now, even though the problem doesn't tell you you have to, one thing you need to know about this is that without knowing the total resistance of the circuit, you can't solve this problem. This is a simple series circuit and there are no junctions. So the current coming out of the battery, the total current, is equal to the current going through 1 and is also equal to the current going through R2. So what governs the current that comes out of the battery is the total resistance of the circuit, which in a series circuit can be found by simply adding the individual resistance values. So here we have 5 ohms plus 10 ohms. So V equals IR, therefore I equals V over R, and if you're trying to find the total current, which we are, you need to use the total voltage and the total resistance. So the total voltage was 45 volts, and we just found that total resistance as 15 ohms, so we're left with 3 amps for our total current. Now again, because this is a simple series connection, the current's the same everywhere throughout this circuit. So the total current is equal to the current going through resistor 1 and is also equal to the current going through resistor 2. So all of those values are 3 amps. Once we have the individual currents, we can easily find the individual voltages or the voltage drops. V equals IR, so if you're trying to find V1, you use I1 times R1, which would be 3 amps times 5 ohms. And if you're trying to find V2, you use I2 times R2, which is, again, the 3 amps. Now this is a 10 ohm resistor. Always keep your subscripts consistent. If you're looking for a third value, for example, if it was a V3, you would use I3 and R3. Now for part C, this is an interesting question, and it's really just to emphasize a point. The total value for the voltage we already know is 45 volts, but we can do a little check because this is a series circuit and we can apply the loop rule. The total voltage of the battery should equal the voltage drops going across the 2 resistors in this series. So if we take a look at our answers from part B, we would expect that our voltage drop across resistor 1 plus our voltage drop across resistor 2 should total up to be the same as the voltage gain for the battery, and we find that it is.